Hello everyone. Today we shall discuss about the mechanics of capillary action, an investigation into how liquids spontaneously defy gravity. You can see here the sketch of capillary rise, and you'll find here the capillary rise here. Blue liquid water rises up the narrow glass tube against gravity. This is known as capillarity or capillary action. Here the adhesive forces between liquid and glass is greater than the cohesive forces in liquid. That is the reason why it rises up. Adhesive forces between liquid and glass is greater than cohesive forces. What are adhesive forces? Adhesive forces are the forces which act between the liquid molecules and glass molecules. And cohesive forces are the forces in the between the liquid molecules only. Suppose if you take water, then the attraction between the water molecules is known as cohesive forces. And the adhesive forces between water, suppose this is glass, the glass, then this force is greater, the force of adhesion is greater than that of cohesive forces, so water rises in a capillary tube. Here also say that a capillary represent mercury. Here in the cases, cohesive force is greater than adhesive forces. Cohesive force means the attraction between the mercury molecule is more than that of the adhesive forces between mercury and glass. That's why the meniscus is like this in mercury. And in water, the mercury it is concave and it is a convex shape in mercury. So if you go to the second phase, what you get is the phenomenon standard capillary rise. Capillary rise is the spontaneous movement of a liquid up or down a narrow tube against the force of gravity. No pump, no mechanical force, driven solely by molecular interaction. In capillary rise, the water rises up to certain height. And you can see this is in the form of meniscus and it is concave in shape. The reason is that I already told you the adhesive force is greater than the cohesive forces. Now the third part what we get here in that the permanent marker, the molecular tug of war. You see adhesion means attraction attraction to the tube walls. Adhesion means attraction with the molecules of water or mercury to that of glass. That is adhesion. Cohesion, attraction within the liquid. That is attraction within the liquid, that is cohesion. In water, adhesion is greater than cohesion. In water, adhesion is greater than cohesion. So water rises in a capillary tube and it is in the form of meniscus, that is a concave meniscus. Right? So here you see that in water, adhesion is greater than cohesion. And the third point is wetting versus non-wetting. If it is glass and water, the meniscus will be in this way, that is, it is concave. It forms a concave meniscus, concave. But in mercury glass, it is form a convex meniscus. It form convex meniscus. Wetting, adhesion is strong. Here the adhesion is greater than cohesion. Adhesion force, adhesion is greater than cohesion in case of water glass, cohesion. And in case of mercury and glass, the cohesion dominates. Therefore, cohesion is greater than adhesion. Cohesion is greater than adhesion. The shape of the meniscus reveals the dominant force. Water rises up because it wants to stick to the glass. Mercury falls because it prefers to stick to itself. Here the cohesion force is greater than the adhesion force. Next point is that of the lifting engine surface tension. Think of the surface as a stretched elastic skein. Surface tension attempts to pull the liquid surface in the smallest possible area. This creates an upward pull of the liquid column along the contact line. So the surface tension is the reason why the liquid rises in a capillary tube. The next important thing is that of model the Jurin's law. This is very much important. The Jurin's law says that H is equal to 2 sigma cos theta by rho gr. Sigma is the cos theta, angle theta is the contact angle, this is the liquid density, g is the gravity, r is the radius of tube, and a height of rise will be this. The height of rise will be 2 sigma cos theta by rho g r. And the differs numerator 2 sigma cos theta. You see surface tension. Higher tension, stronger skin, higher climb. If the surface tension is more, it will high, go up. Contact angle. Smaller angle means better weighting. As theta approaches 0, cos theta approaches 1. Maximum lift. So it will be maximum. It will have a maximum lift. If the angle theta is small, it has a maximum lift. The height will be more. And the resistance, the denominator. Density. Heavier liquids are harder to lift. It is inversely proportional. H is inversely proportional to density of the liquid. Gravity. Stronger gravity pulls harder against the rise. And R, radius, the width of the tube. The width of the tube is inversely proportional. R is small, the H will be more. So it is inversely proportional. So this is the Jurin's law for. Now the radius factor. You see here the H is inversely proportional to 1 by R. The height is inversely proportional to radius. The smaller the radius, the more it will rise. A smaller space, less weight of lift related to surface area. So if the R is small, height will be more. You see, in the case of 3, height is more. It is medium and it is low. So it depends on R also, radius of the tube, and height is inversely proportional to the radius of the tube. Next one is field notes, the nature's engineering. Nature's xylem cross section. This is, you see here, it is xylem cross section. Plants rely on capillary action to transport water from roots to leaves. The xylem acts as a bundle of microscopic capillary tubes, initiating upward transport against gravity. So it acts as a capillary action. So the xylem acts as a bundle of microscopic capillary tubes, initiating upward transport against the gravity. Number 2, field notes, wicks and lamps. Architect's daughter. An oil lamp, wick, works by capillary rise. The tiny spaces between the woven fibers act as micro channels to rise up. Adhesion of oil to fiber greater than gravity. Adhesion of oil to fiber is greater than gravity. And here the field notes, porous materials. Architect's daughter font. Sponges and blotting paper absorb liquids because they are full of voids. These voids act as thousands of random multidirectional capillary tubes. Summarize the logic of lift. Adhesion is greater than cohesion. Concave meniscus forms. Surface tension pulls up. Right? Capillary action is the victory of surface interactions over gravity in small spaces. So these are the various important things we have learned in regard to capillary action. Thank you everybody for watching this video.